Hello, hello, what ho! Welcome back to another exciting adventure of The Plain Truth. I'm your host, Travis Finley. This is going to be a video trying to demonstrate what I understand is happening with inferior mirages as opposed to what the mainstream idea is. And let me adjust this. Okay, I think that should be okay. Right there, whatever, okay? All right, how does that work? All right. Okay, here we go. This is from Andrew Thomas Young's SDSU Refraction Magnum Opus. Introduction to Mirage Simulations. A mirage is an image of something. So, before making simulations of mirages, you have to decide on what object is to be miraged. To simplify the work, the object should have a simple shape. So I chose a 90-degree triangle so that the sides slope at 45 degrees. In addition, I've painted some stripes on it, blah-de-blah-de-blah. Okay? To understand mirages, it is very useful to know what the scene looks like without a mirage. Correct. Correct. Absolutely. Okay? So here is, well, I guess maybe I'll just, because I'm probably going to repeat myself, so I'll just do it this way. At the top of the simulation is the ray diagram. This is the ray diagram right here. This is the ray diagram, okay? Showing fans of rays that enter the observer's eye. This is the observer. I would have liked for him to perhaps put the object, the triangle or something like that here. So these are all the rays of light coming from the object into the observer's eye, according to him. Okay? The right end of each ray is marked with its apparent altitude at the observer in minutes of arc. 2 minutes of arc, 1 minute of arc. That's horizontal, negative, negative. Okay? Give me a second. The vertical scale at the left side is the height in the atmosphere. You can read off the observer's height. Sorry. You can read off the observer's height by noticing where on this scale all the rays converge. The horizontal scale is the horizontal distance. Oops. Okay. The horizontal scale is the horizontal distance, which is actually curved because in his world the Earth is curved. The plot is correct in rectangular coordinates, so the heavy line represents the Earth's surface as concaving downward. Okay? So the thing that I understood eventually is that this line back here is the horizon. Now, he doesn't say this, but it's implicit in the concepts, okay? So we have a target with no mirage right there, okay? And that becomes an opportunity to show you what that looks like here, okay? Here is this house with no mirage. Okay, there's no mirage. Now, it's not going to be a perfect comparison to what Andrew Thomas Young is trying to do, but this is just simply then land that's behind, this is land behind the house. That's what this is. This is water farther behind his object that he's depicting here. Okay? So What I want to do right now, I think, is try to remember what I wanted to say. And I think that that's going to be by bringing this in. Okay, this picture here is is his fourth step in these mirages. All right, let me show you this. Okay, so here's the first step, no mirage. Here's the second step where he's moved his observation back 1 kilometer, and you're starting to get this inferior mirage. And then you've got more, and then you've got even more. Okay, so this is for him. This is, he's moving the distance back 4 times. Okay, so let's go back up here to the image with no inferior mirage. Like, how does this compare, right? The way that we need to think about this is that the tips will line up, right? Okay. All right, let me try to think about this. Okay, so what I'm trying to show you is this. Okay, this is what I'm trying to show you. Okay, here we go. Okay, here's the object with no mirage. Okay. Now, what you have to understand is that when I slide the transparency over here, nothing changes with the image physically, right? This is still here. You just can't see it because it's behind the mirage. Okay? The horizon is still right here. You just can't see it because it's behind the mirage. Now, the thing about Andrew Thomas Young is that when you have the horizon, the apparent horizon here with the mirage, he thinks that that's curvature. But it's not. It's the result of the mirage developing and changing with distance as he increases it. Okay, so this... All right, I'm back. So I thought of something after I wrapped up, and I'm just going to do this real quick. All right, this is from Andrew Thomas Young. Inferior Mirages, an improved model. Just some points to bring to your attention. This is from Andrew Thomas Young. The lower edge of an inferior mirage at sea forms the apparent horizon. Now, I don't know whether or not he understands the ramifications of what he is saying, but I'm going to try my best to explain that here. Okay, we have an inferior mirage here with platform Gina, which is roughly 10 miles away. Here is the mirage of the platform, and this is the mirage of the sky all the way across. All the way across. There's still... Okay, so he's talking about the image that you're looking at here. This is creating the apparent horizon here, but you have to understand it's doing the same thing here. Okay, the ramifications is, or the ramification is, this is not Earth curve. Ever, ever, ever. Okay? This band of mirage represents physical distance from the platform to the horizon, much like the shadow of a tree that stretches out over the ground. You got to think 3D. Okay? You've got the y-axis across, you've got the x-axis going into the distance. Okay? So let's pretend like this is the house. Okay? Within that band, there's the ground. The ground is right there. Okay? That is the reality of what you're looking at. So I don't know, again, whether or not Andrew Thomas Young understands the ramifications of saying that the lower edge of the inferior mirage at sea forms the apparent horizon. Okay, I've got more examples here for us to look at here. All right. So here we have the Anacapa Island. Here is the lighthouse. This is 19 miles away. Here we have an inferior mirage. Here, all right here is an inferior mirage. Right here, that's not physical island. That's water. Okay? Water is going continue. This is what is creating the limit of this water here, according to Andrew Thomas Young. The lower edge, of the inferior mirage forms the apparent horizon. Okay? So this is sky up here, sky, 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 not sky. This is a mirage. Okay? Now, just for shits and giggles, here is the island. Ay, ay, ay. Oh my goodness. How do I get a hold of this island now? Okay. All right, so, right, look at this. Let me look at, if we're going to scale this, come on. Look how big that lighthouse is. I have to make this thing huge. Look, you telling me you think that this island is down behind this curve? Come on. Come on, son. Come on, son. Okay? This island is all right here. It's all right here. What's happening right here is magnification. Look how big, right? Okay? It's not difficult. This is not difficult. This is where the island physically is. And that's where the arch should be. Why can't you see the arch? Because it's in the mirage. Okay? Let me go back to our esteemed, venerated, atmospheric, astronomical guy. Inferior mirages are familiar sights today over smooth roads. An observation that goes back at least to 1800. But the earliest observations were over bodies of water. They are mentioned in antiquity. The hiding of distant objects by the mirage and its variation with the height of the eye were recorded in the 18th century. Right here? The hiding of distant objects. Okay? I'm sorry about that. Whatever. So, why can you not see? Why can you not see the arch? Because the mirage is hiding it. It's all right there in front of you. This never goes behind a curve. It never gets brought up in front of the curve. Or, I'm sorry, it never gets brought up from behind the curve into your line of sight. Everything you're looking at here is always right there 100% of the time. All the time. I'm not going to slow down. Don't stop me now. Okay? So just as a way of contrast, okay? Right there you can see this right here. You can see it right there, okay? So everything is right here. What's the obstruction for us? It is the conditions of the medium. All right, so now let's bring that over here, right? Let's do that. Whatever. You can never get this thing to scale. It's never going to be to scale. The image that I'm messing with right now is taken from a mile away. Okay? So if you want to, make all of this fit, it's a big hassle because it's never going to match. It's never going to match. Okay, but I have images of the from this same vantage point. I have images of this island and what's it? Okay, let me show you another one that'll just boggle your mind. Right here it is. There's the arch right there. There's the arch right there. This is where the island is. The island is up here. Okay? This is mirage. This is mirage. This, according to Andrew Thomas Young, at sea, the limit, the edge of the mirage creates the apparent horizon. And you have to understand that it goes into the sky as well. Okay? Got it? All right, let me pull up just real quick these images here. Give me a second. I don't know why my glasses always get like this smudge and I don't feel like I'm touching them. Give me a second. Say hi to each other. Be nice to each other in the chat. All right, where am I in this? I am looking for images of the island. Okay, here we go. All right, these are all from the same location. I mean, look at that, right? See, look, I can't even put this, like, here's the lighthouse. I'm going to match up the lighthouse. What the hell is the Crack-a-Smurf arch doing over here? What is this? What is this? I cannot get it. I have too many things hiding in the background here. Okay, so there's the arch there. Where's another shot? Here's a good one. All right, so this is the actual water line here. Okay, see how blue, 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 dark blue, that's distance. This is where the water line actually is. This right here is an inverted image, and this is it reverted. Okay, we've got two things going on here. Okay. This is where it is. It's getting inverted and reverted. Okay. This is gonna when the right people see this and decide to be honest with us. Look at the lighthouse is over here. Look at this. Absolutely crazy. The lighthouse is right there. This doesn't work to scale. You can't scale this stuff. Blink test. Can't do it. When the right people get a hold of this, this is going to rock. This is going to rock. Absolutely. Is there one more thing to show you, I suppose? Let's see what this one does. Yeah, that one's okay. I think there's another one. That's okay, so look at this one. Right? Now this is from a different location. I'm just going to tell you that. So the parallax is different here. All right? But there's you can see the lighthouse. I'm going to put the lighthouse together with this. Boop. Look, I mean, look how much space, right? Okay. Crazy stuff. Okay, you can't blink test this stuff. Absolutely incredible. Right? Okay. I think that's all I had in my mind when I was trying to think about something else, and let me look and see. Is there anything else real quick? I have so many pictures. So many pretty pictures. Okay. Now, one thing that Andrew Thomas Young talks about, and I don't put a lot of stock into it because, again, I believe it's a construct created by the concept of living on a ball, right? So all of these interpretations of these mirages are based on the assumption that we are looking over a curved surface. So then they're not making these observations and drawing conclusions from them. They are assuming the Earth is a sphere, and then when they see things that change, they attribute that to Earth curve. And then they have to work the model into refraction. And in my opinion, it just does not, it creates more problems than it solves. Okay, so real quick, right here he says this: with the lower edge of the inferior mirage at sea forms the apparent horizon, which is depressed below the astronomical horizon by the dip. Okay, so not going to try to belabor this too much, but we've got a nice little shot right here. You can clearly see the change in color right here. Okay, now I believe that that's what he would probably consider the astronomical horizon, because the astronomical horizon is somewhere here above the surface of the Earth, and then the dip down to where the horizon happens is that transition. But I don't know. I mean, I just haven't done enough, but sometimes I want to say that this is actually showing us where the horizon reaches. Okay, the horizon reaches beyond this. I know that sounds crazy, but there it is. There's the arch, right? Right? Put the arch right there. Nothing matches up. Can't match it. Can't match it. There's the light. See it? Boop. This doesn't work. You cannot blink test this. But it's right there in front of you every single time. When you cannot see this, it's not behind curve, it's behind refraction. Okay? All right. That's enough. I love you all. Have a wonderful Taco Tuesday. I'm going to go get some empanadas and Mexican rice and beans. Arrivederci, uchi uchi. This is 1 kilometer away. This is 4 kilometers away. But what you have to understand, what's not changing right here is I suppose to a certain degree it might be, but it's angular size, right? So if you're increasing distance, right, the background is 1 kilometer away. And I'm going to have to switch this pointy finger to behind, or I mean in front of, right? Okay, there we go. Okay, forgot what I was going to say. This background image is 1 kilometer away. This image is 4 times as far away, which also means it's going to be smaller in angular size. So everything is going to change. But the only thing that I want you to understand is that everything in the background is still here with these mirages. You're not rolling over a curved surface. Okay, the horizon is not coming up in front of and obstructing anything. This is not Earth curve here. This is not Earth curve, okay? So let me do this and then switch back over to my creations. All right. So this is the demonstration of the image without an inferior mirage, okay? Now, the thing that's going to be different about my demonstration is that I'm not increasing my distance. I'm just showing you other photographs with an increase in the refractive index so that it compensates for, it's as if I'm moving farther back, okay? All right, so now this is now as if I've moved back 1 kilometer. All right, and so now we've got an inferior mirage here. Okay, but this water is the limit to this water is created by the inferior mirage, which means that try to just make it similar, which means that the ground that you see right there is right there. Everything's still there. Trying to scale this. Refraction's a bitch, but I love her. Anyway, so you see what I'm saying, okay? So we're going to keep that there for the next one. All right. So now you've got the house. All right. Now we're going to have to adjust this because it's moving farther. See, the Aetherband does all of this. This is moving it back for us. The mirage is creating this appearance as if we're moving farther into the distance because we have more right? There's all this. This is all still right here. This is all still right here. Okay? The inferior mirage is growing. Okay? This apparent horizon is not Earth curve. This one's a little bit easier to see because it's it seems to be blending into. You can see birds on the water and things like that, but the compared to the last image, you've got a harder line here. You know, it looks, oh yeah, that's curve. That's curve. It's a hard line. All right, so let's get to the third one. All right, so now we're at the third one. Okay. All right, so now you see the inferior mirage. It's coming down all the way right here. Everything is still here. Everything is still, this is not behind the curve being brought up. You are looking over distance every single time. Every single time. So when you go back to Andrew Thomas Young here, you're looking over the same distance. Let me get this out of the way. You're looking over the same I don't know, physical distance. I don't know how else to say it, right? Curvature did not come in here. Curvature did not come in here. Curvature did not come in here. Okay? This is the house is right here. But there's an inferior mirage below it. Okay? It's just moving into the distance. And then the inferior mirage gives the appearance of an apparent horizon here, but the apparent horizon is created by the conditions of the medium. All right? I don't even know. I can't remember what I've said and what I haven't said. I think that that's about as close as I'm going to get to, unless something else comes to my mind. I think I had something else just to show you. Okay, so I guess I'll just do it because I have this one pulled up. All right, see this house right here? Just pretend like this is the house, right? It's right there. It's right there. And this sailboat is right there. That's the sailboat. The sailboat's right there. Okay? So then this shows you the inferior mirage. Let me try to match this up, so give me just a second. Okay? See that? How's that work for you? Okay? This is all just moving into the... this is just like if I was moving farther and farther away. These observations look different every single time because of the medium. This could be farther away. It could be closer to me. Okay? So just like you cannot see the shoreline here, but it's right there, just like you can't see the shoreline. The shoreline hides things that are behind it. I'm sorry, the mirage hides things that are behind it. The mirage also creates the apparent horizon. Okay, this is not... If I just showed you this if I just showed some baller this picture with this boat, yeah, it's the horizon, dude. It's the horizon. No, it's not. That's completely refraction. 100% refraction. Every single time you see a boat like this out in the water, this is what's going on. It's not just one effect. It's not just an inferior mirage. There's also stuff happening in the proximate distance to you. Everything's being affected by this medium. 100%. So, all right. Well, there you go. Trying to keep it relatively short. This has been another exciting adventure of The Plain Truth. I'm your host, Travis Finley. If you have any desire to interact with me on this, then please, by all means, check out my email address in the description box. And this has been another exciting adventure of The Plain Truth. I'm your host, Travis Finley. Until next time.